Okay, continuing the normal distribution, you need your stats tables with you, and we are going to start off with an example all about trees. There we go. There's a tree, and on that tree there are some leaves. There's a leaf. Okay, and these leaves, we are looking at the length of a leaf. So we're going to go straight into an example, and we know the length of these leaves, well, we're going to call that L, uppercase L for our random variable, and L is going to follow the normal distribution, and I'm going to put here 10, 9. What can you tell me about the significance of those numbers right from the start at this point here? That 10 and that 9, what do we know about them? 9 is the
standard
is the variance. Yeah.
And 10 is...
So the variance is 9. So what other useful bit of information can we get from that straight away?
Standard deviation is 3.
Yeah, standard deviation equals 3. What symbol do we use for standard deviation?
Lowercase sigma.
Lowercase sigma. So that's lowercase sigma squared. And the 10
Is that the mean?
is the mean, and the notation we use for that?
Big X?
No.
The
mu.
gun shape.
Yes. Okay, that one. Mu. The Greek letter mu, spelled M-U. Okay, the first question is going to be, find the probability a leaf is less than 12 centimetres. Okay? Right at the end of last lesson, we left, to a certain extent, the talk of Z's behind, and we started instead to do another sort of notation with a phi symbol. Is there anybody who can confidently tell me how I can go straight to a phi thing here? True, but not needed. If it's less than, I like it. Remember, your tables are less than tables, so if it's less than, I like it. No need to do anything else about that bit. Yep.
Just in the books, they put like less than equal to. It's like, what's the right way of doing it?
doesn't matter.
The Billy principle. See me, the Billy principle, yes, means it doesn't matter, okay? Because if I put an extra bar there, it makes no difference at all, because the probability it's 12 is 0. It's a continuous thing. Okay, so that makes no difference at all.
What do we have to change it into?
So, I want to put down something now with this phi symbol here. This O with a diagonal line sort of going like that. And then after that, I put something in brackets. Can anybody remember what goes in there?
Is that 12 minus 10?
Yes?
12 minus 10 divided by 9?
Not quite.
3.
Yes. So, what has gone in there? At this stage, I'm doing phi of x minus mu over sigma. Remember this thing here we said last time, this is z. If you take the mean away and divide by the standard deviation, you end up with a new random variable z, and that is tabulated in the formula books. So that's our z. Here, when you normally use x, and here really I suppose it should have been lowercase l because we're using big L, but it doesn't really matter. So I now need to work out what 12 take away 10 or divided by 3 is. 2/3, okay? The tables you use are all in decimals, so I need that as a decimal, and the tables you use can work up to 3 decimal places. So, yeah, 0.667. So we now go for our tables, page 19 of the OCR tables, and here we go. 0.6 is where my finger is. 0.66 is where the pen is pointing. And then I need to add 7. Hang on, I'm going to swap a pen and a finger there. So I need to add 23 onto 7574. I need to add 23 onto 7454. What do I get if I add those on?
0.7477.
7477 is correct. So that is 0.7477. But from last lesson, if you have got your mu value, your sigma value, your x value, you should, if you know what you're doing on your graphics calculator, be able to go straight there and type it in. Your graphics calculator may not give you an exact answer sometimes, particularly if you use 2/3 here, your graphics calculator would probably be working everything out to about 10 decimal places or something like that. So you may be slightly out, but the examiners know that, and that's okay.
Will we be expected to do this in the exam?
You'll be expected to do this to be able to
Yeah.
do this in the exam.
And would you need all the workings? If you can do it in a graphics calculator, I'm guessing you can't just jump from...
Yeah, I would say that you don't have to write that bit there down, I wrote in a different colour, but I would expect to see that written down for this question in an exam. Yes?
In the formula chapter, it's got like the normal distribution PDF, is like the horrible thing.
Yes. On what page is that?
8.
Page 8. So you spotted on page 8 there, the horrible thing. Yeah, it's there. You don't need to use it. You will never need
We
to
never
use
have
it.
to use that.
Okay? No. Okay. You will never need... So it's telling you here what the mean and variance are. And you won't forget that anyway by the time of the exam. And these things over here, this column here, you'll never use for anything anyway.
So what if they gave us a question where we need to use the formula because there was some value that was missing or
You
something?
won't.
Okay.
That will not happen. You will not need to use the formula. You would just use those tables. There are questions we're going to come across today where there are things missing you've got to work out, and we'll see that sort of thing in a minute. So, we'll move on to the next part of the example. I'll stop this clip here and start a new one.